The atomic bomb, a weapon of unimaginable power that changed the world forever. It harnessed the forces within the atom, unleashing destruction on a scale never before seen. The sheer magnitude of its power was both awe-inspiring and terrifying. Scientists worked tirelessly, delving into the mysteries of atomic energy. Their efforts culminated in a device that could obliterate entire cities in an instant. This single invention changed the course of human history. It marked the beginning of a new era, one where humanity had to grapple with the potential for self-annihilation. It ushered in the nuclear age, a time of both great promise and peril. The world stood on the brink, with nations racing to develop their own nuclear arsenals. The atomic bomb's creation was a scientific marvel. It represented the pinnacle of human ingenuity and the relentless pursuit of knowledge. It was the culmination of years of research and development involving some of the greatest minds of the 20th century. The Manhattan Project brought together scientists, engineers, and military personnel in a massive collaborative effort, but it was also a harbinger of destruction. The bombings of Hiroshima and Nagasaki left an indelible mark on the world, showcasing the devastating consequences of nuclear warfare. Its use in World War II demonstrated the catastrophic potential of nuclear weapons. The immediate loss of life and the long-term effects of radiation were a stark reminder of the bomb's destructive power. The story of the atomic bomb is a complex one. It intertwines scientific brilliance with political intrigue and human tragedy with technological triumph. It is a story of scientific brilliance, political intrigue, and human tragedy. The ethical implications of its use continue to be debated to this day. It is a story that continues to shape our world today. The legacy of the atomic bomb influences modern nuclear policy and international relations. We must understand this story. By studying the past, we can learn valuable lessons about the consequences of our actions. We must learn from the past. The memories of Hiroshima and Nagasaki serve as a solemn reminder of the horrors of nuclear war. Only then can we hope to navigate the challenges of the nuclear age and build a safer future. By promoting peace and understanding, we can work towards a world free from the threat of nuclear devastation. At the heart of the atomic bomb lies a process called nuclear fission. This groundbreaking discovery changed the course of history and science forever. This process involves splitting the atom, a concept that was once thought impossible. The idea that such a small particle could unleash such immense power was revolutionary. Atoms, the building blocks of matter, contain a nucleus made of protons and neutrons. These tiny particles are held together by powerful forces. In certain heavy atoms, like uranium, the nucleus is unstable. This instability makes them prime candidates for nuclear fission. When a neutron strikes the nucleus of a uranium atom, it can cause it to split. This splitting is not just a simple division, it is a violent reaction that releases a significant amount of energy. This splitting releases a tremendous amount of energy, far more than any chemical reaction. The energy released is in the form of heat, light, and radiation. It also releases more neutrons, which can then go on to strike other uranium nuclei. These neutrons can then strike other uranium nuclei, causing a chain reaction. This chain reaction is self-sustaining and can continue as long as there is enough fissile material. This chain reaction of splitting atoms is what gives the atomic bomb its power. The rapid succession of these reactions releases an enormous amount of energy in a very short time. In a fraction of a second, countless atoms are split, unleashing a devastating amount of energy in the form of heat, light, and radiation. This energy is what causes the massive explosion and destruction associated with atomic bombs. The power of nuclear fission is both awe-inspiring and terrifying, a testament to the incredible forces at work within the smallest particles of matter. The development of the atomic bomb was a race against time. World War II was raging, and the Allied nations feared that Nazi Germany might develop the bomb first. This fear spurred the United States to launch the Manhattan Project in 1939. The Manhattan Project was a top-secret program. It brought together the brightest scientific minds from the United States, Canada, and the United Kingdom. The goal was simple: to build an atomic bomb before Germany did. Scientists and engineers worked tirelessly for years. They faced daunting challenges, but their determination never wavered. Finally, in July 1945, the Manhattan Project achieved its goal. The first atomic bomb was successfully tested in the New Mexico desert. The Manhattan Project developed two types of atomic bombs. The first was the gun-type bomb, codenamed Little Boy. This bomb used uranium-235 as its fissile material. The gun-type design was relatively simple. It worked by firing a subcritical mass of uranium-235 into another subcritical mass. When the two pieces combined, they formed a supercritical mass, initiating a nuclear chain reaction. Think of it like a gun. One piece of uranium-235 acts as the bullet, and the other piece acts as the target. When the bullet hits the target, the explosion occurs. Little Boy was a powerful weapon, but it was also inefficient. It required a large amount of uranium-235, which was difficult and expensive to produce. Section 5. The implosion-type bomb, Fat Man's complexity. The second type of atomic bomb developed by the Manhattan Project was the implosion-type bomb, codenamed Fat Man. This bomb used plutonium-239 as its fissile material. The implosion-type design was more complex than the gun-type design. It involved surrounding a plutonium core with conventional explosives. When these explosives detonated, they created an inward pressure wave that compressed the plutonium core. This compression increased the density of the plutonium, causing it to reach a supercritical state and initiate a nuclear chain reaction. The implosion method was more efficient than the gun-type method because it required less fissile material. Section 6. Hiroshima and Nagasaki, a day the world changed. In August 1945, the United States made the fateful decision to use atomic bombs against Japan. This decision was influenced by the desire to bring a swift end to World War II, which had already claimed millions of lives and caused unprecedented destruction across the globe. The first bomb, Little Boy, was dropped on the city of Hiroshima on August 6, 1945. The explosion was devastating, releasing an immense amount of energy equivalent to approximately 15,000 tons of TNT. It instantly killed tens of thousands of people. The intense heat and radiation caused severe burns and radiation sickness, leading to even more deaths in the following days and weeks. The blast wave flattened buildings for miles around, and a massive firestorm engulfed the city. The once vibrant city of Hiroshima was reduced to rubble and ash, with very few structures left standing. 3 days later, on August 9, 1945, the United States dropped the second atomic bomb, Fat Man, on the city of Nagasaki. This bomb was even more powerful than the first, with a yield of about 21,000 tons of TNT. The Nagasaki bombing was even more powerful than the Hiroshima bombing. The destruction was immense and the loss of life was staggering, with tens of thousands more people killed instantly and many more suffering from the after effects. The use of atomic bombs on Hiroshima and Nagasaki had a profound impact on the world. It not only brought about the end of World War II, but also marked the beginning of a new era in human history. It ushered in the nuclear age and forever changed the nature of warfare. The bombings demonstrated the devastating power of nuclear weapons, leading to a global arms race and the establishment of international treaties aimed at preventing the proliferation of these weapons. Section 7. The aftermath, a legacy of destruction. The aftermath of the Hiroshima and Nagasaki bombings was horrific. The immediate effects of the bombs were catastrophic. The blasts and subsequent firestorms killed hundreds of thousands of people. Many more would die in the years to come from radiation sickness and cancer. The bombings also had a devastating impact on the environment. The explosions released massive amounts of radiation into the atmosphere. This radiation contaminated the soil, water, and air, causing long-term health problems for the survivors. The psychological impact of the bombings was also profound. The survivors, known as hibakusha, faced discrimination and stigma. They carried the physical and emotional scars of the bombings for the rest of their lives. Section 8. The Nuclear Age, a World on Edge. The atomic bombings of Hiroshima and Nagasaki marked the beginning of the nuclear age. The world was now faced with a new and terrifying reality, the possibility of nuclear war. In the years that followed, the United States and the Soviet Union engaged in a nuclear arms race. Both countries built up their nuclear arsenals, each trying to outdo the other. The threat of nuclear war loomed large over the world. The Cold War, as it came to be known, was a time of great tension and anxiety. the world lived in the shadow of nuclear annihilation. The Cuban Missile Crisis in 1962 brought the world to the brink of nuclear war. Section 9. Conclusion. A call for peace. The atomic bomb is a stark reminder of the destructive power of technology. It is a testament to human ingenuity, but also to human folly. The legacy of the atomic bomb is a complex one. It is a legacy of both horror and hope. We must never forget the lessons of Hiroshima and Nagasaki. We must continue to work towards a world without nuclear weapons. The future of humanity depends on it. We must find a way to live together in peace, without the threat of nuclear annihilation hanging over our heads. The choice is ours to make.